Now let us solve few questions based on arithmetic progression. Here it's given that for an AP, the first term is 4 and the common difference is 2. And we have to find T7 and S9. That is, we have to find the 7th term and the sum of first n terms of the given AP. Now here let us write the given data in symbols. That is, the first term is given to be 4. So that is A equal to 4 and the common difference D is 2. Right. Now we know the formula for writing the general term Tn as A plus n minus 1 times D. Alright. So therefore, putting in the values, the 7th term will be nothing but 4 plus 7 minus 1 times 2. So that gives us 4 plus 6 into 2, 12. So therefore we have T7 as nothing but 16. So that's the first answer. Now we have to calculate the sum of first 9 terms. So that means here n is equal to 9. Now let's write the formula for Sn. As we know, Sn is nothing but n by 2 into bracket 2a plus n minus 1 times d. That's the basic formula for Sn. Alright, so putting in the values here, n by 2 is nothing but 9 by 2. Now 2a is nothing but 2 into 4, which is 8, plus n minus 1, where n is 9. So 9 minus 1 is 8, multiplied with the difference d as 2. Okay. So that in the bracket we get 8 plus 16, which is 24. So that gives us 9 by 2 into 24. So cancelling 2, we have factor of 12. So that gives us 9 into 12 as nothing but 108. So therefore the required sum is nothing but 108. Right. Now let's go ahead to the next question. For a sequence, it's given that Sn is equal to 2n square plus 5n. Show that it is an AP. Right. Now here, to show that it is an AP, we have to show that the difference between two consecutive terms is a constant. That means it does not depend on n, that is a term number. Alright. Now how do we make use of the given data? That is, we are given the formula for sum of n numbers or n terms in terms of n. Right. So here if we consider, say for example, the terms in general, that is t1, t2, t3, t4 dot dot dot, we will have tn minus 1 and tn. Okay. So we have n terms. So sum of n terms, that is Sn, is nothing but sum of first n terms, that is Sn, as shown here. Now if we want to show the difference between two consecutive terms to be same, alright, somewhere we have to show that the difference between any two consecutive terms to be same. That is, we are free to choose any two consecutive terms. But since here nothing is mentioned about any specific value of n, so we have to take any generic pair. Alright. So let's try to prove that difference of tn and tn minus 1, that is difference between the last two terms, is constant. Okay. So this is what we try to prove, and by constant we mean it does not depend on n. Right. Now as shown, if we have Sn as the sum of n terms, we can get the sum of n minus terms, n minus 1 terms. That means we will get Tn in terms of n. Alright, if we subtract Sn minus Sn minus 1. So that means n term is nothing but merely sum of n terms minus sum of n minus 1 terms, isn't it? Now let us substitute the expressions for these two, that is Sn is nothing but 2n square plus 5n minus, now to write Sn minus 1, wherever there is n, we will replace it with n minus 1. So 2 into n minus 1 the whole square plus 5 into n minus 1. Alright, so which in turn gives us 2n square plus 5n minus, now into bracket, whenever we open the square we have n square, which when multiplied with 2 gives us 2n square alright. Then the middle term is minus 2n gets multiplied with 2, so that gives us minus 8n, and we have plus 1 which gets multiplied with 2, which again gives us plus 2, and opening the second bracket we have 5n minus 5. Now we have to club all the like terms, and therefore I will write Tn as equal to, now if you see that 2n square is going to get cancelled, then similarly 5n is also going to get cancelled, right? So what remains is minus of minus 8n, so that is nothing but 8n, and we have 2 minus 5 which is minus 3, when it comes outside the bracket that becomes plus 3. So therefore now here we get the formula for nth term of the given sequence. Now the only remaining step is to calculate the term which comes just before nth term, so that is we want to find out now Tn minus 1. Now since we have got the formula for any term in general, we can easily calculate Tn minus 1 as wherever there is n, we will replace it with n minus 1. So that gives us 8 into n minus 1 plus 3. So that further gives us 8n minus 8 plus 3. So which is nothing but 8n minus 8 plus 3 is minus 5. Alright. And lastly, whatever we wanted to confirm is the difference between the consecutive terms should be constant. So let us see what do we get. We have to find out Tn minus Tn minus 1. Alright. So that is Tn minus Tn minus 1. So if we see Tn is 8n plus 3, and from that if we subtract 8n minus 5, then 8n and 8n will get cancelled. So 3 minus of minus 5 is going to give us 8. So that means here we observe that the difference between Tn and Tn minus 1 is 8, which is a pure constant. It does not depend on n. So therefore we have proven that consecutive terms have the difference of 8, which is constant. Therefore the given sequence is an arithmetic progression.